Hello. Am I audible?
Yes, sir.
Shall we start?
Yes, sir.
Hello. Ganesh.
Yes, sir. Hello.
Shall we start?
Yes, sir.
Hello. Am I audible?
Yes, sir. You are
Yes, sir,
audible.
you are audible.
Okay. I hope I should revise few things of yesterday. Have you understood, or I should do it briefly? Anyone? Akshay? Ganesh?
Sir, please repeat once.
Okay, let us start. So basic thing was we have to develop a linear classifier which can separate two classes using a simple thing, that is line or plane. That is our concept, and whole thing is to find out proper line so that I can do this. So I assume that my line is of this form. I think it's not visible. So this is my assumption. To adjust the line position, I need to adjust W vector of this line, that is collection of all weights and the constant Wn plus 1. So there are n plus 1 parameters to be adjusted for a line or a plane so that this partition is adjusted properly for a two-class problem. Now if there are multiple classes, then I may have to adjust different such lines so that all are properly classified. So we took an example of three-class problem. So there are three prototypes. You can assume that they are centroids of three classes. Okay, and then finally we are asked to test what is class for 5, 5. Then I just plot these three prototypes. From this I understand that this is a line which partitions prototype 3 and prototype 2. This line separates prototype 1 and 2, and this line separates prototype 1 and 3. Now I may find out these 3 lines, equation for these 3 lines. Here what I'm going to do is, instead of that, I'm going to form 3 different functions. Say G1 x for class 1, G2x for class 2, and G3x for class 3. So 3 functions will be designed. Basically they are planes in this case, and I know what are their equations, how to find out the equations given a prototype. So a plane, suppose this plane, this is a tilted plane, this plane is another tilted plane, and this is another tilted plane. So these 3 planes, they will meet and form these decision boundaries. So I can design these 3 planes using these 2 equations. So GIX is constituted with WI and WIN plus 1, where WI is equal to XI and WIN plus 1, this is a simple number which is XI transpose XI multiplied by half. So if I, for a given problem, if I keep on doing this, I can form 3 equations that we have seen in these 3 equations. And then you will see that if you plot using your computer, you will see that these 3 planes are formed due to G1x, G2x, G3x. Now beauty of these 3 things is that if you test something for unknown, say I am standing here for unknown sample X test, then I just check which function is producing largest output. In this case, you can visualize that G3 will produce largest output. If I stand somewhere here, then G2 is going to produce largest output. If I am backside, then G1 is going to produce largest. So whichever is producing largest output, that is the class of that input sample. So this, we can make an arrangement like this, where this node is implementing G1x, G2x, and G3x. You see, all are receiving same inputs. I can even join them, so like this. Okay, so these are common terminals, and this is a constant terminal 1, which is representing Wn plus 1 component. So this is W1, this is W2, and this will be W3 in this case. So there are 3 parameters to be adjusted to obtain G1x, G2x, G3x. So whichever is producing largest output, that will be, the index of that will be thrown as the output class. So this is very simple. So that is what we have shown here with an example. For as a curiosity, suppose you want to find out, say this line equation S13 between class 3 and class 1. Suppose I want to find out this equation, how I can obtain, any guess? If I want to find out boundary S13, for S13 I can write G1x is equal to G3x. The place where this happens is the boundary. So I can just equate It is 10x1 plus 2x2 minus 52 is equal to minus 5x1 plus 5x2 minus 25. So if you simplify this, you will get the decision line between the two classes. Similarly, you can equate g1x is equal to g2x. You will get decision boundary s12. Then you can equate g2x with g3x and you will get s13. So that was the thing. With the help of, I can say, graphical and analytical way of doing the things. Now we are moving towards a system where the network will find out weights on its own. We will not visualize or dictate or find out somehow weights of the decision boundaries. We will supply only data. We are going to supply samples one by one to the system, and system will evolve with its own to obtain weights. That is what we want in neural networks. So neural network is like a black box where you are just feeding data. It will learn on its own. It will adjust itself and produce required result. So before I do that, just try to understand what is linear and non-linear problem. As I said, if I am able to draw a simple line or a plane between two classes or multiple classes and my job of classification is done, then it is a linear problem. We'll see that if I want to draw such kind of non-linear decision boundary, and plain simple line equation like w1x1 plus w2x2 and so on up to wnxn plus wn plus 1, this will not do. This equation is going to just draw a line or a plane. To make this kind of a line, I may require something else, maybe w2 x2 square and so on. So I don't know. So to make such kind of decision boundaries, it's a difficult thing. Even difficult thing is making say, such kind of boundaries. See, in this case, class 2 is completely surrounded by class 1. So these are non-linear problems. So remember, when I say a perceptron, when I say a perceptron, it can draw line or plane. It cannot draw this. So it can only solve linear problem. But there is a trick to solve all such kind of problems using again neurons. So that we will see later. Now the concept that helped me to do this is non-parametric technique or non-parametric training. Sir, class चालू आहे. The thing is, I want to learn directly from data. Now this is the portion that we have seen yesterday. Maybe it was confusing, so I'm just repeating yesterday's portion. So try to differentiate feature space and weight space. So here the axes are features x1, x2. And when I draw a line like this, as usual, equation in W transpose X, Wn plus 1 equal to 0. This line is drawn in feature space. So if I collect the coefficients of space variables, that will form W vector, which is perpendicular to this line. Note that this W vector is always perpendicular to this line drawn. Suppose I take 2x1 plus 5x2 plus 3 equal to 0. So if I collect this 2 and 5, this is W vector, which is always perpendicular to this line. So once this is done, you will see if I declare g of x is equal to W transpose x as a function, and if I substitute different values of x, that means if I choose this point and put the coordinates of this into this equation, the g of x is negative below this line and it is positive above this line. In short, if you follow the direction of W, the g of x is positive, and if you are opposite side, it is negative. So when a sample is given to you, say like this, then this is suppose first training sample, and you have suppose randomly assumed weights for a perceptron like this. Then you have drawn a line like this. So this is your first input. So this weight is directed towards this. So this side is positive and this side is negative. Now note that the sample belongs to class 2. That means when it is class 2, I want output to be say -1. But class 1, I want +1. So as you know, the perceptron activation is sign of U transpose X. So if I take a sample or a point from this side, the line, then I am going to produce positive result. So this sample is above the line, so it will produce positive. But I want here negative because my sample is class 2. So what is to be done? So instead of the earlier line, which I was lying say here, I have to now tilt this line so that this sample is below the line. So this new line is adjusted. This is the old one. New line is adjusted such that this sample falls below this new line so that W transpose X is negative. So this is called as training. there was error earlier in previous case. So this was why this error came, because I have randomly assumed some line initially. I don't know the patterns, so I just randomly assume this position. Then my first pattern came. Then I say, okay, this is producing error. I will change the line. So I change the line from this position to this position. Now this is properly classified. So what we are actually adjusting here, can you identify how I have tilted this line to this position? What is in my hand? Any guess? Anybody? How I can change position of line? Somebody. Okay. So how to change slope? Shubham? So as he's saying, you have to change the slopes. So slopes are actually controlled by W1, W2, and W3 in this case. So if I play with W1, W2, W3 of this line, that is W1x1 plus W2x2 plus W3 equal to 0, then I can adjust the line. Okay. Now to visualize this thing properly, instead of feature space, now I just move to augmented weight space. So what is this augmented weight space? Suppose I have W1x1 plus W2x2 plus W3 equal to 0. I can write this equation in this form. So I just collect weight variables and then I collect space variables. I call this as now y. So y is now x1, x2 and 1, and w is now w1, w2.
Sir, PPT is not visible.
Not visible. Okay,
Not.
just 1 second. Now,
Yes, sir, visible.
okay. So which part you missed? Can you tell me this last point? You were able to listen to this?
Yes, sir. Sir, from that equation.
Okay. So what I did is just I'm collecting weight and make a vector. Then I collected x1, x2 and this 1 associated with w3, and then I make W transpose y equal to 0 as new equation. So it is just an adjustment. There is nothing special here. What is beauty of this is that this W transpose y will always W transpose y equal to 0 will always pass through origin. When I go to this equation, there is a constant term, so that will make a difference. So I have smartly adjusted this line into augmented space, augmented weight space. What is augmentation here is this W3 component and one component here. So this is a smart way of adjusting the things. Now you see that instead of x1, x2, my axes are now w1, w2. In this case, I should have a third axis w3 coming out of this board. So that will be a 3D case. Now if I take as for simplicity a 2D case, then this will be a weight space of 2 dimension, and if I draw a line here, then it is W transpose y equal to 0. So if I draw a line W transpose y equal to 0, that becomes my equation. Then if I take this y vector and plot here, which is input training pattern. Now my tuning parameters are W. So this line W transpose y1, I know that since this is perpendicular to this y1, this will be having W transpose y1 is equal to 0. What I want to say is, if you give me any pattern now, say this pattern, suppose y2, because I am going to give you one by one training samples and you are going to adjust weight accordingly. Now I will explain why this is more helpful to visualize in augmented space. If I plot this y2, this is my suppose second pattern, then I know that to classify it properly, I have to draw a decision boundary which is perpendicular to this line, and if this is class 1 sample, my weight must be this side of the line. If my weights are below this line, then it is going to produce negative results. So let us see in detail. Suppose I have the first training sample y1 which belongs to class 1, and I randomly assume w1 as my initial weight, say which is lying here. If my input is y1, I just plot this vector y1. Say this is some number, maybe -2 and +2. If y1 is given to you is -2 +2, I just plot that point and join this with origin. So that becomes y1 vector. Since I am in augmented space, I know that equation for decision boundary is W T transpose y1. So this is the line where W transpose y1 is 0. But what I want for y1 is that W transpose y1 should be greater than 0 because y1 belongs to class 1. Now see, if w1 is lying over here, which is below the line. If it is below the line, I'm going to get negative results. So I want positive. So what I have to do is I have to push this weight above the line. So I should go to positive region of this line. So I'm just pushing this. So I can push with any path like this. But the steepest path is this, the line which is perpendicular to this, isn't it? So if I take gradient of W transpose X with respect to W, or W transpose, I should say Y in this case, this is Y. So Y is this direction, which is already, we know that this is perpendicular. So gradient of this function W transpose Y is Y. So what is gradient? You have to differentiate this with respect to W. So this is the path you should travel so that you will be in the positive region. Now how much you should travel? I can go here up to here also. I can go beyond this also. So how to control? So we control using the learning constant C. So I should put a small value of C or sufficiently large value of C so that I will travel from this point to this point. Suppose you put some random value of C. So if I start with this W and I travel only this much in first iteration, then you will find in second iteration still this sample y1 is misclassified. Then again you will adjust your weight in this direction so that you will reach properly and classify that sample. So this is why neural network takes time to adjust lines automatically. So what it overall what it is doing is it is adjusting line parameters, or in multi-dimension is plane parameters, so that for all training samples this W is adjusted such that everybody is satisfied and classified properly. So with a neat diagram, if I want to discuss, same thing is I start with W1, then this Y1 was given to me is from class 1. Since I am in the negative zone of this decision line, my answer is wrong. So I should travel in a positive direction like this. So that is how I adjust my weight. Now you can see what is beauty of weight space. You can visualize how your weights are traveling. So you are traveling like this. So this is the path so that you travel in proper way. Now take opposite case. So you can see what I am doing in nutshell. It is, this is new value W prime, so old value, and I am adding a small vector. So this is y vector and I am multiplying it by some small number C, maybe 0.5, and then a small component of that is added with W. So you are here and you are traveling here. That is what this equation is showing. Now the case is different here. In second case, this is my pattern, but it is now belonging to class 2. Earlier thing was it was belonging to class 1. Now it belongs to class 2. That means desired response for class 2 is -1. Now you see that you are here. Your initial guess is here. In this case, suppose, then you applied your first pattern, that is y1, which belongs to say class 2, and This is the decision line, that is W transpose Y1 equal to 0 because of Y1. Now your weights are here, that means you are in the positive zone, but you want negative output. So your weight cannot be here to classify Y1 properly. So you have to throw this weight with the shortest path somewhere in this zone, which is called a solution area. So again, this path is the gradient path, but in opposite direction. Gradient of W transpose Y1 is this direction, but you are traveling in opposite direction, so it is negative gradient of W transpose Y, right? So this is positive and this is negative. So now instead of plus that we had done earlier, I am going to subtract. So we do subtraction from weight. So change in weight, if you see carefully, is plus or minus Cy. So new weight W prime is equal to W old plus or minus Cy. So now I want to implement this idea. Now take a 3 samples example. I was traveling, initial guess is here. I started my journey with sample 1, which belongs to class 1. So this is the direction of Y1. That means this is positive direction, this is positive zone, and this is negative zone, compared as taken reference of this line. Y1 is plotted over here, and this is perpendicular line, that is W transpose Y1 equal to 0. But your weights are here, so it will be producing wrong answer. So you will be traveling with gradient, and suppose you move to W2. Now you are here with new weight, then you obtain your Y2. See, this is my Y2. Y2 is saying this is the direction of positive of this W transpose Y2 equal to, so this line is W transpose Y2 equal to 0. So this portion is W transpose Y2, which produces positive, and this is the region W transpose Y2, which produces negative. Since my input is class 1, I have negative output here. My weights are below this line. So I should travel in this direction so as to make my output positive. So if I, instead of this place, if I keep my weights here, then this Y2 is satisfied. Y1 is already satisfied. Since you are here, which is below this line, you are already in the positive zone of Y1 sample. Now due to Y2 sample, my positive zone is now reduced to this much. If you are anywhere in this zone, your outputs are negative. Now you apply your third sample, which is here, which actually belongs to class 2. Then you are standing here. This Y3 direction is this. This is the positive side of the line, this is the negative side of the line. And since my input is class 2, you should be above the line. Okay, so you have to throw this weight in this direction and come to this place. So because of these three patterns, this is the solution zone. So if you are having your weights anywhere in this zone, you are in solution area. All three patterns are classified properly. This is a very key idea. I don't know how many of you could understand. If you have a doubt, you can ask. Otherwise, I will assume that you have understood and I can move ahead. Anybody? Dhananjay, Ganesh, Akshay, Mrunal. I can see your names, so that's why I'm saying. Is this clear? Bhagat is saying explain. So what I should explain? Can you tell me briefly which part I should explain? Or this example once again? Okay, just very briefly. Assume that I am standing here and first pattern is given to me, which is y1. So this is my y1. I plot suppose this y1. Say y1 is maybe say 2 minus 2. So that is the direction of y1, and y1 belongs to say 2, I should say minus 1. So y1 is belonging to class 1. So I just plot that. So that is the position, and then I know that W transpose y1 should be W transpose y1 equal to 0 is this line perpendicular to this pattern. Since my weights are here, I want positive output. Actually, it will produce negative output. So I should throw my weights here. If I'm standing here and take second pattern, which is y2 of this direction, then if I plot here y2 and then draw a perpendicular line, then since my weights are below this line, they are here, I will get negative answer. And since my pattern class is 1, I want positive output. So I have to throw this weight to new position. Then I take third pattern and I find that it is class 2 pattern, and this is the line due to that pattern. And since it is class 2 and I am in the negative zone of the line, I want positive. Sorry, I am in the positive zone of the line since this is the y3. Y3 is this side, so this is positive part of the line. I want negative, so this is negative of this particular line. So I should throw my weights here. So if in total, if I combine all these three patterns position, then my solution is lying over here. There are infinite solutions of this problem within this particular zone. That is what the training of neural network means. This is training of a neuron only, the single neuron training. Okay, so we will take one example in next class. Possibly you will try to understand more. So before I start that, you can read Zurada again right now so that these things are clear. You can ask me questions while I am teaching. There is no issue, so that I can explain more. So I think I could record this lecture today. So I will post this today only. Okay, just go through it again, and you can ask me question next time. Okay, thank you.